Okay. Good evening, everyone. Thank you for joining us. So it's great to see everyone here again today. I'm Karen, and together with my colleagues, we run the StackX community here in GovTech. So before we start, we'd like to run through a couple of house rules that are on screen now. First, please take note that the webinar is being recorded, and we ask that your questions be kept to the topics presented today to keep the session meaningful. Please feel free to ask or upvote questions throughout the webinar through the Q&A function at the bottom of your screen. But please avoid posting questions in the main chat, as our speakers won't be taking questions from there. The program tonight is an exciting one. Rachel, next slide, please. Yes. The program tonight is an exciting one. GovTech's GitOps teams will bring you through the practice of how it is used in the public sector. This will be followed by a question and answer session where you can ask Samuel and Ernest questions. So before we invite our speakers to share, we'd like to give a quick introduction on GovTech to our new attendees here today. We're currently about 3,000 strong, and our work can be broadly classified into these three areas: products, services, cyber, and governance. So under the product team, we have over 700 developers, including Samuel and Ernest, who implement product for the whole of government and develop strategic national projects. We have capability centers in digital services, sensors and IoT, data science and AI, cybersecurity and infrastructure. So we also have the infrastructure team under the products side, which they manage infrastructure from our move to the commercial cloud to managing of data center to issuance of devices to public offices. So under the services group, we have more than half of GovTech here. They play an important role in managing technology in over 60% of government agencies in Singapore. And in the last pillar is the cyber and governance. GovTech is the cybersecurity lead for government, and the Government Chief Information Security Officer sits within GovTech. And to ensure that all the work that we do is safe and secure, our governance group sets ICT policies and guidelines across government. So to engage and connect with developers and engineers like yourselves, GovTech has formed this StackX community since 2019. If you have not joined the community, the Meetup community, we invite you to scan the QR code that's up on screen now. And I'll also share the link in the chat shortly. So we share a wide range of tech and tech-related topics, and updates on our latest StackX meetups will be shared with community members through this meetup page. So do feel free to join us. So to engage the developer community like yourselves, we have launched the Singapore Government Developer Portal. Visit us to discover some of the products that government has developed, such as the National Digital Identity, the API Gateway, and some of the documentation for these products that you can try out as well. So do check out our community page where we will share some of these videos on demand, which includes past webinars and blogs that we will be sharing, uploading from today's event. So we are continually improving the portal, and feedback on what you'd like to see more of, how we can do better is always welcome. So we invite you to scan the QR code here that is up on screen to give us some feedback on essentially how we can do better. I've also pasted the link on the feedback link in the chat. So we're keeping our fingers crossed that the COVID situation improves for all of us. During this period, we are continuing our support for the tech community. We have close to 400 positions available for contract and perm positions. So whether you're a software engineer, DevOps engineer, or BA, you will be able to find interesting roles here. And we'd like to do a quick call out for the developer portal team that is looking for a full stack engineer. I'll share the link to the careers page shortly. So if you know of friends who may be keen or have been displaced during this time, please feel free to share it together with them. So without further ado, please join me in welcoming Samuel, our GovTech software engineer, who will give an overview of GitOps and how it's being used in the Singapore government. Samuel, over to you, please.
Good evening, everyone. Thank you for attending today's StackX Meetup. Today I'll be talking about GitOps for government. Thank you, Karen. So today I'm just going to do a very basic breakdown of what the GitOps workflow is like, nothing too complex. First, just a little introduction of myself. My name is Samuel. I've been working in GovTech, Government Digital Services, for about 6 years. I was one of the first engineers that worked on the design and implementation of Nectar, the first Kubernetes platform for the Singapore government tech stack. In this role, I've actually done a fair bit of developer advocacy. I've been talking to the services group that Karen mentioned, encouraging Singapore government agencies on how to design their systems with microservices and build the infrastructure with Docker containers hosted on Nectar. Today, I'm a member of the cloud engineering team. We are a cross-divisional team working to improve the government commercial cloud, which is basically our cloud hosting environment on AWS, Azure, and GCP. We work to encourage the adoption of cloud-native solutions and DevOps practices across the Singapore government. So I'm sure many of you have heard what is DevOps and GitOps. So this is just a basic overview. GitOps is a movement by DevOps practitioners to shift their operational processes to rely on the Git repository as the single source of truth. That's a lot to unpack, so I'm just gonna break it down for you. As a developer, I'm sure you want to automate your work as much as possible. You don't want to do things like, oh, I need to fill up a Word form, a Word report, Microsoft Word report, and say I need to follow all these. I need to execute all these change processes, right? There's all this. We have this dependency. We're very attached to our Git platform, right? We do all our planning, coding, building, and testing. That's all done on the Git repository. That's what we do as developers. When it comes to releasing our code, when it comes to deploying, releasing, deploying, operating, and monitoring our systems, right? Very often we find that we either hand it over to another person, an operations person, someone who will go into the manual, do it manually, right? They'll go into AWS, they'll go and set up your VMs, they'll configure the network for you. Then you have to wait for them to do all this deployment work. And this can be very manual, right? If your team is small, you also find that as a developer, you also have to do the operations work. And once you do the manual deployment 10 times, 20 times, you want to find a way to automate all of this deployment work rather than creating VMs manually. So GitOps is simply using a combination of tools and automating the whole process using the Git repo. So this combination of tools, we have infrastructure as code. We use infrastructure as code files tracked in version control. We use very comprehensive CI/CD automation, and we use Git merge requests to trigger all of this. This GitOps workflow allows software developers to shift left all your testing and approval processes. You can take a lot of your manual operations work and shift it left. You can incorporate it into your automation. And most importantly, you don't have to go anywhere else other than your Git repository platform to deploy changes to your system. So I've covered declarative infrastructure as code. DevOps practitioners use infrastructure as code languages such as Terraform, CloudFormation, AWS CloudFormation, Azure Blueprint, and GCP Cloud Deployment Manager to express the state of your cloud infrastructure. What does that mean? If you can see the very tiny screenshot, basically, you can write a script to tell the AWS API or the Azure API or the GCP API how to create your cloud resources and how to configure those cloud resources. If you are an enterprise organization like GovTech or any member of the Singapore government, you have to create many tiers, right? Maybe the web app DB tier, and even the integration tier and the gateway utility tier, and you have to create all kind of firewall rules, very complex firewall rules to link up all the different tiers, all the components in different tiers. Doing that manually leaves room for error. So it's actually better to do it all by scripts, and that's what infrastructure as code is. And in GovTech, we actually recommend the use of HashiCorp Terraform, which is a platform agnostic language that allows you to specify how to configure AWS, Azure, and GCP cloud resources. Then, because we also encourage the adoption of containerization platforms like Kubernetes, Kubernetes also use declarative YAML definition files to configure things like your pods and service routing. So because all of this is code files, these are scripts, right? All of this can be captured in this allows you to capture the state of your system infrastructure. Whatever you have in your version control, right, shows the current state of your infrastructure. When you create changes to this infrastructure as code scripts and deploy it to your production environment, you create a new state in your version control. So if you need to roll back to previous states and deploy new states again, all this can be done through using your Git repository. So since we're using the Git workflow, this diagram should be very familiar to all of you, right? We follow the Git conventions when developing IAC. Every blue circle you see is a state of is a new version in your IAC code. It represents the current state of your infrastructure at the point of time. So as with conventional Git workflow, when you want to make changes to the master branch, you create a feature branch. You create a new branch, you do your changes to that feature branch, and once you have completed your once you're ready to make changes to your master branch, you create a merge request. Create a merge request to put the changes back into the master branch. This merge request is important because it serves as a point of approval for your GTOPS workflow. It also serves as a trigger point for your CI/CD pipelines to deploy your code, deploy your infrastructure as code changes to your production environment. If you have many feature branches, or the way your code, the way your DevOps tool functions is such that it may fail, you may also want to use this staging branch, right? What happens with the staging branch? You can aggregate many different feature branches, and you can conduct more comprehensive tests in your staging branch. And in certain cases, certain scenarios where the DevOps tool, right, there's a chance that it may fail, and you want to preserve the validity of your master branch as showing the most up-to-date state of your infrastructure. You may want to only do the merge after a successful deploy action. So that's also another alternative Git workflow. Okay, apologies for the fonts, but this says merge request triggered CI/CD automation, right? What this slide shows is that modern Git repository platforms such as GitHub, GitLab, and the Atlassian suite, if you use Atlassian Bitbucket and Bamboo, right? They have developed very comprehensive features to facilitate DevOps and GitOps workflows, right? For the GitOps workflow, what we do is we configure the CI/CD pipeline to run test suites on the feature branch once the merge request is created. And a very important aspect of this running of test suites, all the test results are captured into the merge request. This is important for as part of the shift left mentality, where you highlight potential issues with your feature branch as early as possible. Then once the merge request is approved and merged, right, you can configure another CI/CD pipeline to deploy the changes to your production environment. So now that I've talked about the 3 prerequisites for the GitOps workflow, I've talked about infrastructure as code. I've talked about having following a Git workflow. I've also talked about having comprehensive CI/CD pipelines. So this is how the GitOps workflow basically works. When you are ready to merge your feature branch into a master branch, you create the merge request. Once the merge request is created, this will trigger the testing CI/CD pipeline. Then all the build artifacts and test suite reports generated by the testing CI/CD pipeline gets captured into the merge request. And because the merge request is a page viewed by your team, it presents a nice report. All the changes can be reviewed by the team. Now, most of the Git repository platforms offer a discussion thread in the merge request, and this is a very useful platform for capturing all the concerns, all the impacts of the change, right? In fact, you can also continue to work on the feature branch and improve upon it. You don't have to create new feature branches, or you can just use the existing merge request. You can improve the feature branch until it is ready for merging. You can trigger the CI/CD pipeline again and again until all concerns are addressed. And again, notice that I keep emphasizing on the point. There needs to be an approval point in the GitOps workflow, a quorum. So that means if you have a group of people, maybe 2 out of 3 people, a quorum of authorized approvers vote to approve the merge request, right? And once the merge request is approved, you can trigger the deployment. You can merge to trigger the deployment. The master branch CI/CD pipeline is then triggered after the merge to deploy the changes to the production environment. So why is the government so interested in following GitOps, right? It sounds like another DevOps, initiative. Now, the Singapore government, believe it or not, we are very interested in following project governance. What this means is that we must ensure that change management processes are followed, right? We must make sure that we know what change is going to be made, what is the impact of the change, who's going to execute the change, how is he going to execute the change, and what happens if what's the result of the execution of change, and most importantly, who approved the changes in the first place. And believe it or not, we have a lot of paperwork to do this. We do things like we fill out Microsoft Word templates. We create PowerPoint slides to show what is being changed, and to show all kinds of network diagrams. And we capture all of the checkpoints in Excel sheets. If you are a developer, this is a bit of a nightmare, because there's so much paperwork you have to do outside of your day-to-day job as a developer. Now, so that's why we're looking at GitOps, right? All pertinent information regarding the change, including change plans, test results, discussions and actions by approving authorities, all these are captured in your merge requests. It also includes a discussion thread. All this acts as an audit log, right? Okay. There's also the benefit of having all the past and previous states, present and previous states of your infrastructure as code. They are versioned and captured in the Git repository, allowing for recovery and rollback to previous known working deployments. Even if your change deployed today results in some error that was not caught by all your testing, that is okay because you have the previous versions in your Git repository. You can roll back to a previous known working deployment. And if you need to create new environments, right? Since everything is defined as code, recovery from total destruction of your environment, in the extreme case, you could spin up a whole new production environment using the same infrastructure as code. Okay. Then most importantly, this benefits the software developer teams. You benefit from having a faster feedback cycle. Because everything is presented to you in your Git repository software, okay, you can review change reports, you can address change issues, you can approve changes, you can deploy automatically from the Git repository. All this is faster than holding a change advisory board meeting, you know, filing all the paperwork, manually performing changes on your AWS console or Azure console or GCP console, or going into each of your virtual machines and performing the remote administration. And being able to shift left, right, also has other benefits, right? You can catch even more concerns with this very comprehensive CI/CD pipeline, right? From small things such as code validation and linting, if your project team is very pedantic about how you structure your code, okay, you can do infrastructure as code plans and change delta analysis. If you're familiar with Terraform, this is the Terraform plan. And from the Terraform plan, you can actually work out how many new resources are you creating? How many resources are you changing? You can sort of check whether the blast radius is too big. And if it's risky to change your entire infrastructure, you can say, no, let's make the change a bit smaller. Then now, because the cloud is getting a little bit more expensive, right? People are getting more concerned about the cost of deploying new resources on cloud. So you can actually do cost projection using tools like InfraCost. Then we at GovTech, we are quite we are quite forward-looking. We're quite progressive in the sense that we want to develop a policy as code. There's a lot of rules in GovTech where you need to build your infrastructure in compliance with all security policies. And sometimes it can be very hard to do that manually. So what we want to do is to have a standard module, a standard policy as code test to look through your infrastructure and see whether it's compliant with our security policies, our security architecture, right? So tools like Open Policy Agent, which was shared in a previous StackX meeting. We also have things like Chef Inspect that's able to look at your deployed infrastructure and check whether it's compliant with the rules that you write. Okay. Then again, on the security side, we're always on the lookout for vulnerabilities. You can even run static application security testing to ensure your application code is free from known vulnerabilities. And dynamic application security testing, you can use things like Aws Zap to ensure your staging environment is free from known vulnerabilities. So how is government adopting GitOps? We're doing a number of things, a number of initiatives to encourage the adoption of GitOps. We have, as Karen said, our cybersecurity group, we are the lead, and we develop the security policies for Singapore government agencies to follow. We're publishing a newish IM8 DevSecOps policy, and we're also publishing additional guidance on the Cloud Playbook and Developers Portal. All of these publications they offer guidance to agencies on how to adopt infrastructure as code, how to build your secure CI/CD pipelines on SHIP. SHIP is our Singapore Tech Stack Git repository platform. And we also want agencies to be able to leverage cloud-native solutions on government commercial cloud. This is our cloud hosting environment on AWS, Azure, and GCP. We're also working to improve both the SHIP and GCC platforms to allow for greater automation and to enable GitOps for end-to-end development and deployment. So I'm just going to show a few screenshots with GitLab. I didn't pray enough to the demo gods today to show a live demo, but hopefully this suffices. Here I have a screenshot of my very, very basic GitOps demo repo. As you can see, it's quite bare. I only have a couple of Terraform files. The meat of this Terraform file is the main Terraform file. Inside, I'm calling a couple of modules, just very basic modules, to create my web app DB tier. I'm also creating a Bastion VM because I'm old school like that. This is our very basic setup. This is just to show that this is how a system will evolve over time. And since I committed this very basic setup to our master branch, right? This is a screenshot of the CI/CD pipeline triggering on the master branch. This diagram shows that it's deploying to AWS right now. Okay, and if I were to show you a real life production grade VPC, right? It can go up to 300, 400 resources. So this is a very basic example. You can see from the CI/CD pipeline, the standard output is creating a whole bunch of AWS resources, right? And once it's done, this is a screenshot of my AWS console. You can see that it's created my web app DB security groups, complete with all the rules, right? I even have tagging configured for my security groups. If you were to do this by hand, you have to fill up 20 minutes, 30 minutes worth of forms. Not fun. So now this screenshot shows a new feature branch that I'm creating. I'm adding an Nginx service to my basic repo. Here I committed an extra file called EC2 instances web, and just calling another module to add an Nginx image. Once I commit it, it will run some basic CI/CD pipelines. You can also configure the merge request to the CI/CD pipeline to run only when you create your merge request. And this screenshot shows an example merge request form, right? By the way, this software is GitLab, in case I wasn't clear on that. There's a lot of things going on in this merge request page. First, we have who created the merge request. We have a display report for the pipeline that was running for this merge request. Shows that everything has passed. There's a proof button right? This is for those repository maintainers to click on once they're happy with the merge request. Then there's a test report. This test report shows that I run 9 tests and there have been no changes, or everything passed for my 9 tests. And there's another report, a Terraform report, showing how many resource changes are there. There are 6 to add, 1 to change, 0 to delete. And finally, there's your merge button, and there's a text box for entering comments later. So this is where your team goes into the merge request report and looks through inspects all the build artifacts and the test reports. Then your very concerned team members can start asking their questions. Here I have Tom Cruise asking me whether encryption is enabled for my log bucket. And he's also very concerned about how much I'm spending in AWS, how many new resources are going to be created. So that's the kind of conversation you can have with your team members regarding the additions you are making, the changes you are making in your merge request. And then once everything's approved, you can actually merge the merge request into the master branch and deploy to production. Here you can see that the merge request approval was approved by myself, because I'm the only human on this Git repo, and also who conducted the merge request. So if you remember, I spoke earlier about the need for an audit report. This merge request forms your audit log. It captures every concern that was raised by every team member. It captures the exact changes that were made in your code, as well as the changes to the infrastructure, right? It captures all the test reports by your pipeline. And now that you have merged, now that the merge request has been merged, the pipeline for deploying the changes to the production environment is running. So this screenshot shows a series of merge requests that were completed. Please ignore the timestamps. But basically, this is how your project will evolve over time. As you add on more and more services, you will build up an audit log of all the merge requests that have been approved. And that's what you can show to your auditors, that you have followed proper governance processes for your government project. And hopefully that gives you a better idea of how GitOps works and why the Singapore government is so interested in adopting this throughout the whole government. I will now hand over to Ernest Boey. He will talk to you about making deploying to Kubernetes great again with GitOps. Over to you, Ernest.
Okay, thanks, Samuel. Yeah, a very good evening, everyone. Yeah, so hope you're as excited as I am to learn about the different ways to implement GitOps for Kubernetes and some best practices and strategies as well. Just a little bit about me. I'm Ernest, an associate DevOps engineer working in government digital services under the Engineering Productivity Tribe, or EMP for short. So I'm currently working on the Container Stack platform, and in my free time, I build mechanical keyboards and play darts for fun. So Container Stack is a cloud-based container hosting platform that enables the whole of government to focus on application development without worrying about the underlying runtime platform and infrastructure. So Container Stack is part of Singapore government tech stack and is built on Kubernetes. And of course, we use GitOps extensively within the team, and as well as for our platform's users. So we learned a lot during the process of implementing GitOps, which I'll be sharing with you today. GitOps is a rather large topic, so I will limit the scope of today's sharing to these key areas. So firstly, we will discuss 2 different ways of using GitOps for Kubernetes. Second, how to structure Git repositories for GitOps. Thirdly, how to handle deploying to multiple environments. And finally, how CI can enhance the developer experience of using GitOps. So to start, let's begin by introducing Kubernetes and how to deploy applications manually. So essentially, Kubernetes allows users to deploy their applications as containers across nodes in a cluster. So it allows for scalable container orchestration and also leveraging on the wide array of cloud-native tools available today. So configurations are also cloud provider agnostic, which means that most of your configs will work across the different managed Kubernetes offerings by the different cloud providers like AWS and GCP. So there are two main ways to deploy to Kubernetes, imperatively or declaratively. So in short, you can think of imperative as a list of commands needed to achieve your desired cluster state. And that's predominantly seen in scripts. Oops. For declarative, you create YAML manifest files depicting what your configurations for all your components should have to achieve your desired cluster state. And so in this example, if you type this command, you will imperatively deploy Nginx into your cluster using the kubectl command. And on the other hand, you can also specify the Nginx deployment as code in some directory and use kubectl apply command to deploy it. And the command helps to deploy or update components in the cluster such that it matches what's depicted in these YAML manifest files. So suppose you are an engineer and you want to deploy a new application to Kubernetes. So the first step, you probably would code your application and then maybe do some testing, which could be ran locally or also automated in some kind of CI pipeline. And then after that, you would build and also push the image to an image registry like Docker Hub. And then after that, you deploy the application, maybe imperatively via kubectl, and then do some waiting and then test and pray that there's no bugs, issues, or any security flaws. So why pray? Well, because if any issues occur, it would be quite tricky to resolve. Let's take a look at some of the concerns with this approach. Firstly, because deployments are done mostly manually, it isn't very scalable and doesn't allow you to deploy and test frequently, which further delays the feedback loops and also value delivery. And secondly, since there's no change records, it is potentially difficult to replicate environments. So what happens is that your test cluster could be wildly different from your production cluster. So the test results are dubious at best. And then modifying any components inside your cluster will also be quite tricky unless you have some, maybe some full inventory of all your components installed and any of the recent changes made. And even worse, if some incident were to occur, would the team be amply prepared to troubleshoot and also fix the issues? As shown in the slide, you might be asking some of these questions listed, like the details of the issue or how to recover to a working state. And this is actually a good time for some kind of a audit log or a change record system. However, they may require too much documentation overheads or have steep learning curves, which would add a lot of friction when you're trying to deploy changes. So ideally, the change record system should keep track of all the changes, support different workflows depending on your organization's needs, has good performance, and also familiar to most engineers and developers. And that sounds exactly like a great job for Git. So that's where GitOps comes in. With the ability to declare all our cluster components declaratively, it is possible to version everything in Git and resolve our change management woes. So by storing all your cluster and application configurations in Git, Git essentially acts as a source of truth for all changes across time. And this is made possible with the help of IAC and also having all your configurations as code. You also make config changes for operational tasks and application updates the same way as you would if you were developing some applications, which is via Git commands. And after which some GitOps mechanisms, which I'll go through later, will then help with deploying it to the cluster. So GitOps is really useful for engineers specifically in these roles. We have cluster operators who automate provisioning and configuration of clusters, platform engineers who build continuous delivery for developer teams, and also app developers who rely on continuous delivery so that their code can go live. And as for benefits, deploying of all the applications and other components are now automatically done via GitOps. And it also uses the same tool, right? Git, that most engineers are quite familiar with. And this will improve the development experience. And workflows to deploy anything in Kubernetes are now centralized and consistent, not just limited to deploying applications, but also for operations tasks. And by using Git, you also have the Git history, which shows all your different states of the cluster across time, providing an audit trail on the 5 Ws and the 1 H of each change. And then finally, because your entire system is described in Git, you also have a single source of truth from which to recover after an incident, and this improves your reliability. However, GitOps is not a silver bullet. There will be some challenges and considerations, such as that the entire team must have at least some minimal understanding of how GitOps works. And you also need to standardize how you and your team will use and manage Git, such as how you structure your directories, your Git branching models, and etc. You should also limit direct modifications to the cluster to prevent untraceable changes via kubectl from executing. And the team needs to practice a certain level of Git hygiene as well. Otherwise, your Git history will be difficult to decipher, which affects visibility of your cluster state. And next, let's move on to the fun part, which is how to implement GitOps for Kubernetes. Let's start with the traditional CI pipeline, or what we call the push model. So in the push model, an engineer would push source code changes to an application repository, which then triggers a CI pipeline that builds the image. And then he or she can push Kubernetes config changes to a configurations repo or config repo, such as maybe to use a new image or to perform some operations tasks like adding a new cluster-wide component, modifying some networking, etc. And this triggers the deployment pipeline, where some convergence tools like Worth will check for differences in the config repo, which is the desired state, against the Kubernetes cluster, which is the live state. And then any differences that are found are then deployed to the cluster so that the desired and the live state match. However, there are some disadvantages when we adopt this approach, namely this push model. And firstly, the first concern is that what if the deployment fails, even though all the configs were valid? It could have failed due to a variety of reasons, right? Like, for instance, connection issues or issues to the cluster. So in this case, the desired state in Git will no longer match the live state in the cluster. And this will require some kind of manual intervention to restart the pipeline and retry the deployment again, which breaks away from our ideal of trying to automate everything. And then the second concern is that in this push model, the CI/CD pipeline will need to have access to the cluster with cluster-wide permissions. Since it needs to deploy all the configs on your behalf. And this potentially opens in an attack vector, because if the credentials that are stored in the pipeline get leaked somehow, an attacker could potentially have privileged access to your cluster as well. So knowing all this, can we do better? And fortunately, yes, there is a better way, and that is to use the pool model, which involves GitOps operators. So in the pool model, firstly, the workflow for source code changes is exactly the same, right? You make your changes and then the CI pipeline runs. However, the difference comes from how configuration changes are deployed into the Kubernetes cluster now. So rather than triggering a deployment pipeline, a GitOps operator is deployed into the Kubernetes cluster instead. And this operator will detect any changes in the configs repository via Git webhooks or periodic polling, and pull all these configs from the repo to deploy them directly in the cluster. So there are a number of open source GitOps operators to choose from, with Argo CD and Flux being the most popular in the community right now. But I do suggest if you're thinking of which one to use, do look into some comparisons online so that you can decide which is the most suitable for your organization. And moving on to when we use GitOps operators, we get all the benefits that was seen in the push model. And in addition, there are also a lot more automation when it comes to deploying changes, right? So this will save time and effort, and also ensures that there is almost real-time visibility of your live state, which is based on the desired state. And because reconciliation is done continuously, we get benefits like auto retries, auto pruning, and auto healing, which ensure that convergence is eventually reached. And furthermore, privileged credentials need not be stored in any CI/CD pipeline anymore. So the GitOps operator just needs read access to the configs repo so that it can do a git clone and deploy any changes when required. So in addition, GitOps operators are actually no different from any other Kubernetes component. So their configs also can be defined declaratively and stored in Git. The GitOps operator itself can also be entirely self-managed using GitOps tool. So it's kind of like a own self check, own self upgrade, own self kind of situation. Yeah, so now that we know how GitOps operators work, let's talk about some Git strategies, starting with repository structuring. So let's go back to a previous example where we had an engineer who wants to deploy a new application to Kubernetes. And we know that there are several items needed for this to happen, such as the application source code, you have your Docker files, and also your Kubernetes configurations. So in a naive approach, you may be tempted to just create one repository and then store all these files inside. However, there are problems with this approach. And firstly, every commit that you do to your application can result in a deployment. And any new code, which means that any new code may trigger GitOps to attempt to synchronize the desired and the live state, while new configurations may also cause a new image artifact to be built when there's actually no code changes. And secondly, depending on how you structure your repository, everyone may be also able to do a release, right? But that may not be what you want. And lastly, the Git history will also mix app changes with deployment changes, which affects the speed of your troubleshooting due to all the unnecessary noise. So to solve this, well, we could just create separate Kubernetes configs and source code into like different repositories. But should you? And I would say in majority of cases, the best practice would be the option on the left, which is to separate. And this is especially so for medium to large projects that have multiple environments for development, staging, and production. I think rarely you'll be in the situation in the right where unless it's really a very small project, in which case you might prefer the higher cadence of having everything in one repo. So as a best practice, you should split your code and configs into different repos. So most of the time, there will be just one repo for all your manifests for your cluster. But you may further split these config repos up based on like per component basis. But it's generally better to just have one central Git history for visibility reasons. And you would then also have maybe one or more repos for your application source code. And that number of repos largely depends on how you plan to organize and also structure your application. So be it monolithic versus microservices or monorepo versus multi-repo. And to illustrate this best practice further, you will also notice that most of the diagrams shown today will split up code and configs as different repos. As it is ideal to have this logical separation in place so that we can prevent any of the issues that we mentioned earlier. And for larger teams, you may have separate larger teams or even larger projects, right? You may have separate internal project teams working on different aspects of the product. So you may have, and you also may have tenants that are using your platform. So in this scenario, you will need to consider multi-tenancy, whereby each project and tenant should be isolated to their own namespace. So for each project team or tenant, you would then create one config repo and potentially multiple source code repos depending on their needs. And this allows the individual teams to be able to make changes to their own config repo that only affects their own namespace. And you will also need to create a cluster configs repo that is responsible for housing and also deploying the cluster-wide components. And these configuration changes within the cluster configs repo will largely be the responsibility of cluster operators as well as your platform engineers. So the next consideration when implementing GitOps would also be the Git strategies to support multi-environments. So as mentioned earlier, it's quite common for medium to large projects to have multiple environments like development, staging, production. And the configurations and components that are deployed in each of the environments could potentially have slight differences, right? So for example, different number of replicas or maybe different network configurations. So one simple way to just create, one simple way is really just create one repo for each environment, right? But let's see why this may not be the best approach. So while there are advantages such as the fine-grained access control on who can deploy to each environment, there are also quite a number of drawbacks to consider. So for instance, there will be a lot of duplicate configurations across the repositories. And this is caused by, well, the fact that promoting configurations from one environment to another requires, like for example, if you want to promote configurations from staging to production, but that requires you to copy paste from one repo to another. So there's no easy way or no built-in Git mechanism to support this promotion workflow. So it can lead to drift in configurations across the environments over time. So fortunately, there are better alternatives, which I'll briefly go through. So namely, they are having one directory per environment, one branch per environment, and one tag per environment. So do note that there is no best way. So you should take your team's context in mind during any decision making. So for one directory per environment, there will be as many directories as there are environments in your configs repo. So all your configurations pertaining to a specific environment should be stored in the respective directory. And the main advantage is that you get to see all the configurations in each environment at a glance, right? You can just see it straight in the root folder, and the logical separation is very clear. However, there will be a tendency of having duplicate configurations across the environment directories, as you will again need to copy paste them over to do promotion. And there are tools such as Customize that can resolve this issue, whereby you apply environment-specific patches to a baseline of configurations, but there is a steep learning curve to using such a tool. And for one branch per environment, you will create a release branch for each environment. And this allows engineers to use pull requests for promoting changes across environments, which should be quite a familiar workflow to them already. And the pull request descriptions also serve as an architectural change record at the time. However, the configs for one environment may not always be usable in another without some slight modifications. So for example, like your metadata, like labels, and also network configurations again. And this means that your configs in different release branches may eventually drift. And once there is this drift, it is actually quite hard to use pull requests to promote configurations. And finally, you can have one tag per environment. So to trigger deployments, the engineer would retag an environment tag to another commit, or create a new tag and modify the GitOps operator to watch for changes on the new tag. And this approach could be more suitable for very mature projects where changes are done in fixed cycles and also require planning before each release. However, for teams that favor higher cadence, this approach is not very practical, as retagging is a largely manual process. And furthermore, not all your Git providers have features that are flexible enough to restrict who can perform a retagging. Additionally, actually, you can also combine multiple approaches into a hybrid one. So do take note that combining multiple approaches will inherit both the best and the worst of both worlds. So as a result, this wouldn't be the most ideal approach in most cases, because combining approaches can add so much complexity to the workflow that it's simply not practical to use. But however, I think there are rare situations where you need more control on how you carry out deployments, and this could be a viable option. So for example, we could use both directory and branches in conjunction. And so we have GitOps operators in different environments that will watch for changes to specific release branches. And additionally, the configurations for all environments are stored in every single branch. And this allows for easy viewing of all the configurations across all environments at a glance again, whilst retaining all the manual control of when changes are merged into each release branch via pull requests. However, as you can start to imagine, the complexity of this hybrid approach means that the workflow is also very complicated. So for this to be successful, the team must also be very familiar with the workflow and how to react to any edge cases that can occur. So, and in addition, engineering effort also has to be spent so that you can develop some workflow enforcement mechanisms. And last but not least, GitOps is just one part of the CI/CD process. So it is further enhanced with CI pipelines and Git provider mechanisms to provide developers with faster feedback and also adequate protection mechanisms so that we can prevent accidents from happening. So since everything is defined declaratively, we can perform testing on all the configurations for Kubernetes prior to deploying to a cluster. And this can be done using your CI pipelines and automated tests, which prevent pull requests from merging to master, for instance, if any of the tests fail. So some of these tests include using a tool like kubeconform to check for Kubernetes Open API specifications conformity, checking that all your manifests can be generated successfully in the case that you're using customized, execute OPA policies against the manifest using conf tests to test for compliance, and also any other tests that may be specific to your team or your organization. So by having tests done automatically and earlier in the life cycle, defects can be found and fixed sooner. So the developers can also be confident that their changes made has passed a certain threshold of quality and they should pass all these automated tests. And then aside from ensuring that all the tests pass, your Git providers like GitHub and GitLab also have additional rules that can be configured. And this depends on your team's Git branching model. But you may opt to protect certain branches to prevent direct pushes or accidental branch deletes. And you may also want to add manual safeguards like code review and approval, which as well as restricting who can merge certain branches. So with all these mechanisms, developers can feel safe that they won't make any catastrophic errors, especially since Git repo is the Git repo is your source of truth. And with CI and GitOps working hand in hand, your CI/CD workflow will look something like this, with the Git serving as a immutability firewall, which ensures that all your changes to your cluster are recorded. And this is an ideal way to operate and manage deployments to Kubernetes so that it can ensure consistency and reliability. And with that, I've come to the end of today's sharing. We've just barely scratched the surface of implementing GitOps for Kubernetes. So if you'd like to learn more, do check out some of the recordings from past GitOps conferences. And you may also want to join the upcoming GitOps Con that's happening in October. So on behalf of the Container Stack team, thanks for listening and hope you learn something about GitOps for Kubernetes. And if you'd like to learn more about Container Stack or career opportunities in EMP, do check out the links and contact Zhuang Xian from Talent Acquisition. So thanks once again, and let's move on to the Q&A.
Okay, thanks, Ernest. There are quite a number of questions in a Q&A panel. Are you able to see them? I think the first question is, what kind of GitOps tools GovTech uses? Ernest, you want to take that?
Okay, give me a second. What kind of GitOps tools was used in GovTech? Okay, Well, I think this largely depends on which project it is, but mainly for container stack right now, we are using Argo CD as one of the as our main GitOps tool of choice, and that's mostly due to the requirements that we have, right? So because container stack needs to support multi-tenancy, because we have users and different agencies that are using the platform. So we need to provide we need to ensure that natively the GitOps tool is able to support multi-tenancy. And I think previously, before Flux, so right now Flux is in version 2. So previously in Flux v1, the multi-tenancy wasn't as comprehensive as in Argo CD, and that's one of the main reasons we chose Argo CD. And a second reason is that Argo CD has this wonderful GUI, right? So it makes, especially if you give this access to tenants, they will be able to see all their resources that are being deployed much easily from this GUI. You can visualize everything from how your synchronization of your desired and your live state is going, to your health status for all your resources that are currently deployed. So in terms of a user experience, right, especially for a team or an agency that may not have been using GitOps initially, having this GUI is a really big great stepping stone, so that they can be more immersed in the GitOps workflow much quicker. Yeah. So hope that answers your question, ASDF.
Okay, thank you, Ernest. Maybe direct the next question to Samuel. You want to take a question from Ming Lun?
Hello, testing. Okay.
Yes.
Are platform agnostic DevOps tools advantageous in cloud development? It sounds like the flexibility of these tools provide a lot of advantages to different cloud services. Thanks. Platform agnostic DevOps tools, there are a few actually. There are what we call you say you want a load balancer, and it'll automatically translate across to the load balancer Azure, depending on which SKU you want, standard, basic, or premium. And it also translates to the AWS equivalent AWS load balancer, such as, well, there's only one type, ALB or NLB. Yes and no. The nice thing that these tools offer is that you write your code once, and then it will offer you an equivalent, the equivalent in whatever platform you select. And then using that code, you can have multi-cloud environments. However, you need to understand exactly what is it that you're getting from these tools. You may end up with a configuration that you do not understand, and you have to dig very deep to find out, oh, actually I configured an ALB instead of NLB, and that caused this misconfiguration. So your mileage may vary with these tools. In GovTech, we don't really recommend multi-cloud setups, in the sense that there is a lot of cost considerations when sending your data, syncing your data across different clouds. So I'm old-fashioned. I like to make sure that I know what I'm coding. So your mileage may vary. Okay. Hopefully that answers your question about platform agnostic tools.
Okay, Ernest, you want to take one more question, or you're on mute, Ernest?
Oh, sorry. Yeah, sure. I guess the next question we can go to is by Tian Huat. How do you handle multiple concurrent feature branches, their merging and deployment? So this question, I guess, could be also answered by Samuel, but I just give my take on this. So how do you handle the multiple concurrent? Well, I guess this is a very it depends kind of question, right? How does your team structure your Git branching model? How do you what is your strategy for releasing for release, right? So for instance, if let's say all your deployments are done via tagging, then that would also differ versus if you, let's say you have feature branches. But I guess in this context, I think also this depends on the Git provider that you use. So for instance, if you have GitHub or you're using GitLab, I have more experience with GitLab, so I'll share what feature they have so that you can chain like merge requests. So essentially there are merge train. There's this feature called merge trains, which you can specify merge request dependencies. So this will ensure that your merges from your feature branches to your, say, master branch, right, will be in a specific order, so that because I do understand that at certain times configuration changes, the ordering of the configuration changes do matter. So by setting this dependency, it will prevent any of these conflicts from occurring, because you can set the order using such a feature that's found in GitLab. Yeah, hope that answers your question.
Okay, thank you, Ernest. Samuel, there's a few more questions in the Q&A. Maybe I highlight one from Zheng Wei. How do you separate secrets and config management in GitOps? And I don't know whether you want to answer it together, John's question on a good way to integrate GitOps with credentials required in the workflow.
So there are a couple of questions in here. Let me address the secret management. In government commercial cloud, we do offer a central service called secret management. Under the hood, it's pretty much just secrets manager, HashiCorp Vault, right? That's how you manage your credentials. Ideally, you write your automation to query your HashiCorp Vault account to pull your secrets. Alternatively, you can also use cloud-native solutions like the AWS Secrets Manager or the Azure Secret Vault to pull your secret. It really depends on your team. Now, the other thing about configuration management, if you're talking about configuration management, the way I understand it, I believe things like if you use Ansible, Chef, and Puppet, those are configuration management tools. These configuration management tools need to talk to your secret manager to pull the credentials. Or maybe you don't even need secrets. You actually just make use of your IAM credentials or RBAC principles. So there are a lot of ways of avoiding having to use secrets in the first place, or making use of cloud-native tools or the central services that we provide in GCC. Yeah. Okay. Back to you, Karen.
Thanks, Samuel. Ernest or Demi, you want to take one of the questions in Q&A?
Okay. Yep, sure. I see a few shorter questions, so I'll answer them first. Does the GitOps operator in Kubernetes support Helm chart deployments? Yes, at least for majority of the GitOps operators available in today's in the open source operators, namely Argo CD as well as Flux. They both have support for Helm chart deployments. So in Argo CD, you do have to define your application to specify that it is going to deploy a Helm chart rather than using another manifest generation tool such as Customize, right? I think most of the time you'll use, well, this depends on your organization. For Flux, if I'm not wrong, you also are able to use this, there's a source controller specifically for Helm, which basically allows you to deploy or allows a user to wrap a Helm chart as a Helm release, which is a custom resource definition. And this Helm controller will be able to deploy the Helm chart on its behalf. So for Flux, it's a little bit more complicated because Flux separates a lot of its a lot of the GitOps processes into multiple controllers. So you have a lot of bits and pieces here and there. So for instance, if you want to just do the Helm chart deployment, you can actually use one of the Helm controllers to do so. So there's some mix and match that you can potentially do for the GitOps operator. Yeah, I also see another question. I guess I'll just answer this because it's a slightly shorter question. What you shared is the new version of Nectar. that GovTech did a few years ago. Well, I would say it's an evolution of Nectar, because the target audience is slightly different. Nectar is mainly for intranet use, right? And whereas right now we have a container stack which is available on the cloud, right? For the government, yeah. So that it is slightly a different use case, as well as right now for container stack we do have a lot more flexibility in terms of what kind of things can be deployed as if you are a user of container stack. There's a lot more flexibility on the components that you can use because we expose everything as as it is, right? Like Kubernetes configs. So if you're familiar with Kubernetes, you can deploy anything on container stack as well. But you have to ensure that it's compliant, lah. Yeah. Hope that answers your question.
Okay, thanks, Ernest. Samuel, you want to take one more question?
So many good questions. It's really hard to pick.
Yeah.
I'm going to answer this question from John Doe. What's a good way to start exploring GitOps from a personal level? I don't have a lot of resources to play with as a standalone user. I believe you can get started with a free AWS account, a free Azure account, create a fake email. That's what all of us do time and time again. And then you start playing around with your GitHub or GitLab account, and you try to start writing your own CI/CD pipeline. GitOps, I would say it's a collaborative effort, but the road to GitOps is really building your sophisticated CI/CD pipeline. So that's where I would begin. Create your, as I showed you, very bare repo, create maybe a few resources on AWS, and then see how far you can take it, what kind of scripts you can run to test your infrastructure as code. So there are a lot of free resources out there. If you join us, we have all the resources. Yes.
That's a good one, Samuel.
Okay.
Yeah. Could I add on also, especially for if let's say you were trying to figure out how do GitOps operators work, right? Especially for Kubernetes. Well, there's no stopping you from just running a local Kubernetes cluster on your machine, currently whatever you're using now, and just use, because all the operators are open source, right? And then you can just tie them to your personal GitHub or GitLab accounts, and then you can just start messing around and deploying Kubernetes configurations just to play around with how everything works. So there's actually because everything is open source, right? It's really easy to get started, and there's so much information online. From different conferences to lots of online tutorials, and even the official documentation has lots of examples on how to get started. So I think those are great ways to learn more about GitOps for Kubernetes.
Okay, thanks, Ernest, for the add-on. So we have time just for one more question. If you all want to take one each from the Q&A, please.
I will take the one from John Doe. What tools do you use for IEC SaaS testing? IEC SaaS testing. What kind of workflows do you design around this? Who writes the policy? Who does the follow-up and remediation? So SaaS actually applies more towards application code. Say your Node.js dependencies or your Node.js code. I'm a Node.js user in case you don't get it. It's more for your written application code. For IAC, the kind of testing that we want to do is what I mentioned before, policy as code. You want to run your suite of tests, assertions to say that you have web app DB tiers. You have the only specific set of rules from allow traffic from web to app tiers. Those are the kind of policies that you write. For us, the new challenge is to take our very, very comprehensive IM8 security policy and translate that into automated tests. And we would very much welcome you all to join us. As for other tools that we use for testing, Well, a lot of this is built on ship and hats. I mentioned before that this ship is our central Git repo for the whole government, and hats, right, is actually a complete suite of testing tools to test things like quality, response time, and even security. We have a very extensive team managing those two, that combined platform of ship and hats. You can join us and have a look at what it's like to work on these products. Ernest?
Yeah, okay. I guess I'll answer two questions at once. So Adrian asked, what is that design decision of why Kubernetes is used instead of something like ECS on AWS? And also if we are using managed service. So for the if we're using managed Kubernetes, so yes, we are. Currently, we're using EKS. And for what's the design decision on why we use something like ECS? I think this can be brought to another question by Jess Vriel, which asks about what's the benefit of using container stack versus having to create an AKS or any other cluster on GCC. So also, yes, the slides will be shared. Maybe later we'll have more details on that. Yeah, what's the benefit? So essentially, yes, there's no stopping you from just using some your like ECS or whatever. However, in the government context, we do keep in mind that there are compliance that you have to keep in mind, and what the main value proposition that that container stack has is that it's already done all the integrations, all the security, all the compliance, which as you can imagine, right, trying to fulfill all the requirements for say IM8 is going to be a big hassle. Yes, you can use all these cloud providers, but what they're selling you is all these products, but not a solution to how to tackle all these infrastructure or runtime level compliance matters. That if you were to do it yourself, yes, you could, but would you want to spend the engineering effort on that, or would you rather have that worry taken away from you and you just focus on your actual value delivery, which is to build applications, right? Develop solutions that maybe citizens that citizens have. Yeah.
Okay, thank you, Ernest, and thank you, Samuel, for your sharing and taking all the questions today. I must say today I received quite a number of questions for this meetup. So Rachel, if you could bring up the slides, please. And thanks everyone for joining us today. As a closing, we would like to ask for some feedback on how we did for this meetup, how we can improve to do better to help the community, as well as to invite you on the right side to scan the QR code to please join us on the StackX Telegram group chat. We'll be happy to take on more questions by the speakers after this session as well. So the last thing that we have also is to again ask you for some feedback on the developer portal that will be coming up in the next link. So we'll just share all the links in the chat. So do join us in any of the channels if you like. Thanks once again. And thank you, Ernest and Samuel, again for sharing and taking all the questions. Rest well, everyone.